Hello everybody, welcome to the second edition of our program. Thank you so much for joining for the second edition, and we were looking forward to this, and I would like to express our gratitude for your so much of encouragement and support for this program, and a lot of questions are coming from the last time or even this time, though the notice for this program for today has been issued only very few days back, but still we have received overwhelming response from each one of you. I would like to specifically thank all of you for asking questions of very important questions and relevant questions. I have a few requests to each one of you, those who are asking questions from next program onwards. While mentioning your name and email ID, please mention where from you are asking, where is the location, so it will help us to understand the people which are widespread across this country, where from you are asking and what type of interest are there in those regions. That will help us, and also indicate if your age or your some wherever the questions are not asked, what type of studies that you are conducting. It will also help me to frame the answers which will suit you, appropriate for your level of understanding. And if I look at the questions I received for this show, I can classify into various groups. Some of them deals with the interest in each one of you to join ISRO or to become part of the space program. I think many of you are asking these questions from last time onwards. I have been seeing it, how to join ISRO, or how to work in space program, how to become an astrophysicist, of those type of questions. And the second class of questions are more related to the universe and the space technology in general, that you want to understand the global understanding of the space technology and how it affects each one of us, those general understanding. I think this is very interesting to ask such questions. Third type of questions are related to the work that we do in ISRO and what are the future programs and how exciting activities are you are envisioning and how you are trying to do this. The fourth type of questions are related to the programs which has already announced and the status of some of them. I think all these questions are relevant and very important, but I would like to request you not to embark on asking questions on ISRO's regular programs and status. I think this comes out in various ways, and ISRO communicate through various channels on the progress of the activities. But what is more interesting in this session is to engage with the students and budding scientists to show them the way and the path, and then kindle the interest in them to take up science, engineering, technology and related topics to become their profession and passion. And that's a goal that we have envisioned while we have this program ideated. So I would like to help you to ask questions in that area. And I also request you to give suggestions, what you want us to do to help you. If some of you have any suggestions how to reconfigure this program, how you can help you, or if you want to tell us what we should do as a nation, as an organization, some suggestions are there that also can be given. I will be happy to disclose those suggestions for if you find it very interesting and very innovative. And we also look forward to your ideas, especially in the domain of space technology and the space exploration. If you have any wonderful idea, I think I will be happy to share with everybody and then inspire each one of you to work on such ideas. So let me go forward in this edition, look at some of those questions have been that has been asked. But I like last time, I can tell you that I have so many of them in front of me, but I won't be able to cover all those questions. But then many of them are representative in nature, and I am sure that you will enjoy when we discuss these questions. So let me go to the first question where Mr. Kiran Shetty asked this question. What are the innovative strategies that ISRO is employing to address the complexities of deep space exploration beyond our solar system? I think this is very important. I think we have been all the time going around the Earth and then looking at the utility of spacecrafts to study Earth. Then we made the first attempt to go to study the moon, the Chandrayaan programs, then to the Mars. But then we are looking at how to explore other planetary system in the solar system itself. But then going beyond the solar system is possible only with great difficulty, because it takes long years of travel to go outside the solar system. But there is a wonderful thing that we can do. While being inside the solar system, you can look at the universe and then try to understand. This we have already done. I think for your understanding, I can tell you that we have launched a satellite called AstroSat. Precisely, the satellite is meant to understand or unravel the mysteries of the universe. Look at the star formation, the faraway galaxies, look at the black holes, neutron stars, and look at the collisions that are taking place. I think all these are very interesting events that are taking place all around the universe, and we can put a satellite in the space through its telescope. It is possible to look at in a manner which is not possible by other telescopes, because our AstroSat is designed with a multispectral observation capability. So it has given very, very interesting results, and this is something that we can do even without traveling outside our solar system. But of course, we need to think further, and we must find a way to travel outside the solar system, possibly to exosolar planets and beyond at some point in time. And he also asked a question which may be interesting to some of you. How do you decide how many satellites that you can accommodate in a PSLV in a given launch? Many of you may know that sometimes we launch only one satellite, sometimes 2, 3, sometimes even up to 104 satellites. It depends on various requirements. Everything goes with the primary satellite. If the primary satellite has to go to a certain orbit, we design the orbit for injecting the satellite in that particular orbit. After that, if there is enough fuel to go to another orbit, we can plan that. Otherwise, those satellites which is traveling along with them, we call them co-passengers, are destined to go to that orbit. But there are other missions where we put large number of satellites in multiple orbits. We have done multiple orbit missions as well. And the decision on how many satellites is based on how much is the capability of the rocket in the given orbit, whether there is enough fuel to take all of them there, the capacity of the rocket is available to do that, and there is enough of volume in terms of the space available within the payload fairing, whether they can be accommodated, whether the engineering of the whole arrangement allows us to not only mount them, to give them the required characteristics, electrical, mechanical, structural, separation, and various other factors decides to look at position it around that. And we should also ensure that while separating, they don't hit each other. They propagate in a manner with long term, they don't come closer to each other. So various strategies we have to study to decide on how many satellites are required. And of course, we also look at safety. The primary satellite in no way should be affected by the other satellites which are already there. Of course, let me go to the next question from Priyam Gosalia. He asked a question, is it possible to reuse the side boosters of LVM-3 rocket just like how NASA used to reuse its SRBs in the Space Shuttle program? Very interesting question, of course it is. We know that LVM-3 has solid boosters, we call them S200. They are made of steel, and these steel motor cases, after its functioning, folds back into the sea, and if you are able to recover them, then we can refurbish and reuse it. In the Space Shuttle main boosters, there were mechanism by which they were able to be recovered and they brought back, but I don't know whether they have ever reused it. But they made design to reuse it, but I don't think that they have ever made use of the motor cases again, because there are many technologies required to make sure that these motor cases can be reused. In this solid motors, basically I will show you a rocket like this. The two strap-ons, the solid motors on the sides, are the rocket motors. They are huge ones. Its diameter is 3.2 meters. It is almost 20 meters in long, and it costs quite a bit, and if you are able to use them, it will be very good. But while it is falling down, it attains very high velocity, and we have to have parachute systems in this nose cone. While they are reaching the surface of water, the velocity should be lowered using parachute system, and it should impact in water with a very low velocity. Even if it falls in water without the parachute, it will break into pieces, likely to break into pieces, because the water is like a solid rock when it falls, when objects like this fall on it. So it should not deform it, the material should withstand. Another issue is that it has got a hole in the nozzle, and this hole should be plugged because water should not enter. If water enters into it, it will sink before we could go there and collect it. So there are mechanisms by which the nozzle can be plugged and closed. Then there are another technique by which the impact of the motor case in water is minimized and doesn't cause damage to it, and we should be able to locate it and collect it back. But then bringing it back also, we have other challenges. It has to be tugged back from hundreds of kilometers away. then it has to be cleaned without having any corrosion, because seawater is such a corrosive environment. You should be able to refurbish this very fast without keeping it wet for a long time. Inside there are rubber, insulation, so many systems are there. All should be removed within short time, so that material doesn't cause any damage, because these are very exquisite materials. If you expose it to salt water for little longer time, it becomes brittle. So there are many challenges. So we have to work out the cost of recovery versus the cost of the hardware, which is beneficial. And if it is beneficial, and if the hardware is designed for recovery, it can be reused. So let me go further. Mr. Anirudh asked a question. I am very passionate about joining ISRO. Of course, many of you are really passionate. He is asking a question, can you share the details with us about how to become an astronaut in ISRO, and in which mission will your Pushpak vehicle be used? Of course. So let me first ask you, joining ISRO is not for just becoming an astronaut alone. You can become a scientist and join ISRO. You can become an engineer and join ISRO and build systems. And you can also become an astronaut in the future. Since you are interested to become an astronaut, let me tell you that story. Currently, the astronauts that we have, our Gagan Yatris, are all fighter pilots. They are test pilots. The early missions of any human space program will be by them, because they are very well trained to handle these complex missions and physically fit to handle it. But over a period of time, we should be in a position to induct scientists into this program. And when scientists comes, they will be going to space and doing experiments. For example, in our space station, we need people with the science background to come and do such experiments. And of course, there will be Gagan Yatris that will go there and do such experiments. At that time, if you are an expert in a certain domains which is connected with the space science or an astronomy or space technology, you will have an opportunity. So try for it, work for it. Once you are a domain expert and you are able to do something wonderful thing in space, possibly you will find a way when you devise such programs in the future. And you asked about Pushpak. Pushpak is the vehicle is a reusable rocket. It is not of that Gaganyaan program. It is a winged reusable vehicle. It will go to orbit and come back and land as an upper stage recovery aspect. So we are developing this vehicle for two purposes. One, to demonstrate the upper stage recovery of the rockets, and also to use it as a platform for deploying scientific missions in orbit for long duration missions and bringing back after the missions are over. So I have a question from Gokul Krishna Sharma. So before that, I am able to see some good question in this live. Mr. Shushank asked, sir, is there any academic approach? Is everything, or is it the practical learning and skill development to achieve what it takes to a successful scientist? A very good question. It's a very generic question. So first, let me tell you that to become a scientist, especially in the domain of space, you should have both the skills. Your theoretical and academic excellence is very, very important. So you should be very good at the subject that you are working on. For example, if you are an astronomer, you would like to have very good understanding of the astrophysics and related topics, especially physics. Then you should also know how to handle instruments, especially sometimes it could be telescopes. You will have to watch it and then analyze this data, and you should be in a position to publish and compare your work with others who are peers in this domain. So both skills as well as theoretical and academic knowledge, both are important, and it is equally important for any scientific domain, because any scientific discovery except for some theoretical, pure theoretical work like the people like Einstein did, other than that, most of us who are working in the domains of science, technology and engineering work in both the theoretical side as well as experimental side. Of course, there are pure experimental scientists as well. So generally, I can tell you that both are important. Without a good understanding of the subject, the experimental scientist also will not be in a position to produce anything. So you need very high academic background, of course, to become a scientist. So let me continue. Mr. Gokul Krishna Sharma asked, will there be any program in astrophysics for class 10 students? It would definitely be helpful for us. And what are the future plans for research and development of quantum systems? Okay. Now, with regard to astrophysics for class 10 students, I think class 10 students will find it extremely difficult to understand the depth of those problems which astrophysics currently deals with. But of course, you can get a very good understanding of the universe, the structure of the universe, the origin of the universe, how it is expanding, the entire macrocosm which the astrophysicist deals with, where it deals with the various aspects of the cosmos in terms of its origin and its progress, the mass, the gravitation, the rate of expansion, the black holes collisions, the creation of the new stars, the creation of the materials and elements in the system. And there are many such topics which astrophysicists discuss. I think they have reached a very high level of understanding and knowledge through observation and modeling. I think all this understanding requires little deeper knowledge little later. But as a 10th standard student, I would recommend there are a lot of popular articles in this domain which you should be able to read and appreciate and develop this interest. On the quantum area in space, there are many activities, especially in the domain of quantum cryptography and quantum communication. ISRO is working on such projects, and we will also be working on domains like the quantum sensing using special materials development. I think these areas we are already working, and we have a current program to develop a satellite system to be launched to enable us to do quantum encrypted communication networks terrestrially. I think this is one of the goals that we have set as part of the quantum mission of Government of India. Mr. Sharath K. Srijan, I think he is asking a question. Is it possible to create a fully sustainable space colony in the near future? If not, what are the challenges? Fully sustainable space colony means that you should be able to go there, live there, have your food, created water, oxygen, and live forever. Have your families, children, and grow them, and continue as a society. I think such a system, if you have to ever envision, I think this will happen provided that you have a very good ability to transport people and also to create a living ecosystem in another planet. For example, if you are talking about Mars, look at Mars and how to make it into a habitable place. This is one of the discussions that has been happening, and many articles are written about it, how to convert Mars to a terraformed system by which that you regenerate the atmosphere to higher pressure, create an oxygen rich atmosphere. For time being it won't be, but it will take long time, but at least till then you will be living inside a containerized system using the light that you will do photosynthesis, create food there, and people will be traveling from Earth on a one-way mission to Mars. You should be able to create oxygen, whatever is needed from the mineral wealth there, and also water, and synthesize your energy and fuel using those elements, prepare your food and cook and then live with that situations. But there are huge challenges to convert even Mars to a habitable planet. For example, the atmosphere that we have today is such a protection. The ozone layer around us helps us in terms of minimizing the UV radiation effects on us, and the atmosphere helps us in removing the threat of meteorites impacting on the surface, and many other things. So to create a planet like Earth elsewhere and then go and live there could be very difficult for immediate benefit, but then it is possible to live in containerized or enclosures which are specially prepared for us to live in other planets, or even in space itself. Suppose you are able to create a space colony which you will be able to sustain and survive. There are huge technical challenges. Possibly you would have seen in movies of similar large structures that can be taken to space and then create artificial gravity and live there by building systems of this nature. But possibly you may know that we need to move tons and tons of material and masses to the space to create such huge colonies. It requires space transportation capability of that class, and also you also need investment of huge nature to sustain and maintain such infrastructure for long years. Possibly human beings will be capable of doing it maybe a little later, but in the immediate future I do not see a potential to do that unless the Earth is becoming uninhabitable. But that's not our goal, to make Earth an inhabitable place and then move over to space and live there. But to sustain and thrive our life on Earth should be our primary goal, and in case that you need to go and inhabit other planets, you should be able to create it. I think this will happen in a due course of time. Let me go further. There are many questions asked by Mr. Ojas Pandey. I think this is he has asked at least 5, 6, 7, 8, 9 questions, but I won't be able to take all those questions. But so I will take a few of them. One of the question is related to GAGAN mission and how it will impact the future missions and what are this impact on scientific community. This is very, very important for us to understand that GAGAN mission is for us to create the capability of human space travel to space. And why humans should move to create this capability? Because the human being has an ability to do things very dexterous manner, unlike the robots, and we can do a lot of things in space what a robotic system cannot ever do. This is very, very important. And future, if you mentioned about to create a colony of space outside, human beings should get out of the gravity field of Earth, even the atmosphere safety of Earth, and travel to other planets. So human space flight is so important. But then for immediately we look at the capacity creation as a tool for increasing the research content in microgravity environment, especially when you build space stations and go far away to create such laboratories. We should be able to do work in material science, biological sciences, medicine synthesis, 3D printing, additive manufacturing, and various other activities that you can take up in space. And here we have one question from Gokul Krishna. He is asking, what is the potential use of nanosatellites? What are its limits? Okay, very, very interesting that we know we have huge satellites weighing tons, we have mini satellites weighing hundreds of kilograms, we have micro satellites weighing tens of kilograms, and we have nano satellites weighing maybe grams and less than a kilogram. And all of them do certain functions. So every satellite, an artificial satellite that we make and launch, are designed to do a function. So it depends on what type of function that you can do. So function is a result of the payloads that are there on the satellite. So for a spacecraft, there is something called a payload. The payload could be a camera, could be a sensor, could be a communication equipment, could be a radar, whatever it is. So for a nano satellite, if you design it for doing a certain functionality, then you can engineer the whole spacecraft around that functionality. And if you are able to do it in with less than 100 grams, then it becomes a nano satellite. With less than a kilogram, it becomes a nano satellite. And you can do anything with that. If you want to do a communication, you can do. You can do a beacon services. You can collect data from Earth and then retransmit. You can put a small camera and then get the pictures. All this you can do as you can do in a bigger satellite. But it will have limitations of power, it will have limitations of exposure, camera size will be limited, its swath will be lesser, its controllability could be lower than that of a bigger satellites. It may not hold much of fuel for long life, and many other limitations could be there, including redundancy, safety, and things like that. So it's the whole question of weighing one option of bigger satellite versus a smaller. Suppose you are interested in demonstrating certain capability, you will be able to do it in nano satellite much better. But with the advent of very increased integration of electronics and microelectronics coming, even nano satellites are becoming as good as mini satellites in the past. So 1 kilogram satellite is as powerful as 100 kilogram satellite in the past. So this is happening. I think all of you, those who are interested, will be able to get a deeper understanding of it once you start working in that domain. So here there is a question from Mr. Brahmant. I think his question is, what degree is needed to become a chairman of ISRO? I think it's not decided by the degree alone. I think the first thing that you must be working in the ISRO currently, and then you should have a very great contributions that you have done to the organization, various responsibilities that you have held, both technical and managerial, and of course you should be having a certain amount of depth of understanding to understand the complex nature of the work the entire ISRO scientists and engineers are doing across. So you should be able to appreciate and guide them, and you should also have envision what this nation has to work in the fundamental work of the space technology. I think if you have you are able to create such level of understanding through your professional experience and skill working in this domain for years, you are qualified to become the chairman of ISRO. I wish each one of you will one day become as good as I mentioned in various domains, develop your skills and compete yourself to become the chairman of ISRO. Thank you. Okay, let me go further. There is a question from Siddharth from Agra. he asked a question why SpaceX, being a private company, has developed more in rocket development than most of the government agencies around the world. Oh, very good that all of us understand SpaceX is a company which is working in US, and in US there has been a tradition of private companies working in space sector. Possibly you wouldn't have heard about other private companies. Even while US was working in the moon mission, most of the systems were built by private companies, like the companies like Boeing, then the Lockheed Martin, McDonnell Douglas. They were great names who worked in aerospace, defense and space in the US, and they have developed most of the rocket engines and space systems in the US. SpaceX is a new entrant after the US has decided to totally commercialize and operationalize the launch vehicle fleets and satellites. SpaceX and many other companies were given these tasks to develop these systems, and some of the technologies which NASA owned were also transferred to these companies to develop faster. That's how the companies like SpaceX, Blue Origin all came up in the US, and they are doing very well in terms of their ability to develop, fast track the development of reusable rockets, and also accelerate the production of the rockets in a manner that surpassed the launch rates in the past. Even this year itself, you know, they have SpaceX has crossed almost 45 launches. I think it's really interesting to watch this happening. But equally important is to look at the other players in the field. It's not only the SpaceX, the Ariane group which is working in Europe. They are developing their rockets, and the Russians and the Chinese are all developing rockets of various designs. But SpaceX is important because they have been, you know, bringing out new ideas faster, like the Falcon 9, the Falcon Heavy, now the Starliner, which they have trying to launch for people to move to Mars and beyond, a massive heavy lift rocket they have designed. So in the private, they are able to do these type of things because of the support the government is giving, and also the encouragement from the industries, especially the type of new growth that has happened in this sector. The SpaceX has launched the low Earth communication constellation, which contains almost 5,000 plus satellites, and also the future development that they are trying to do, especially the human space flight capability that they have developed in the recent times in the US, and they are the only human space flight vehicle currently available to send humans to the space station from the US. And also the Falcon, the new massive rocket which they have right now built for possible human travel to space and to Mars, etc. I think this gives us a great vision that it is possible for even private companies in India to work and develop this type of capability, and we are all excited to see such thing happening in India as well. There are two companies currently working in India, the Skyroot and Agnikul. They have already tested their engines and made suborbital launches, and some of them are scaling up to have their full launches soon. So we look at with them with great excitement. Let me go further on the questions that we have here. So we have a question from online available. Mr. Mrityunjoy has asked a question. Indian Space Station के बारे में आप क्या सोच है? Space Station के बारे में हमारा एक space station है, भारतीय अंतरिक्ष station. So we have already announced such a station by our Honorable Prime Minister has announced it some time back, and we are working on this idea. It's our target to build and launch the first module of the Bharatiya Antariksha Station by 2028 to be launched using our current launch vehicle capability. But of course, to build a full space station requires new rocket development and much heavier masses to be transported into the space, which we will be working on concurrently. And we hope that by 2035 we should be in a position to have our full space station built with a human space flight access capability to do microgravity research and other activities in space. I have a question from Mr. Faizan Bashir. He asked a question, very simple question, on how to make a profession or a career in space science. I think this is very, very important and a fundamental interest I think all of you are having. Space science is such an exciting thing. It is not limited within the work that is being done by ISRO, but it covers many other scientific institutions in this country who have been working in the fundamental domain, especially in the domain of observation, theoretical understanding of the space and the cosmos, and equally on the engineering side of it to build huge systems that we build in ISRO. And also in the domain of applications, making use of the space technology to develop space-based applications. I think all of this cover the space science area. You will have to choose based on your interest. For example, if you are an agriculture scientist, you are keen to make use of space as a tool to help the agriculture. I think there is a way to help you using imaging, using IoT, using targeted instrumentation. You should be able to help agriculture to do a better agriculture through space technology. Suppose you are a communication engineer, you will be able to develop new space-based communication architecture. Suppose you are an astronomer, you will be in a position to develop new telescopes and observational platforms to understand the cosmos deeper. Suppose you are a theoretical scientist, you should be able to conceive ideas on the expanding universe and look at deeper into the universe and create and maybe formulate some ideas on how the cyclic universe came about. I think many things are possible, but then fundamentally as a student of 10th standard, you are very keen to understand the universe and then create a new interest in space science and technology. Please look at your passion, where exactly you are interested, and develop an interest in it, study very well. Of course, there is something connected with everything for space, and you will be able to find a right journey to space technology and use it for your domain. Maybe a little later, once you get graduated, you will have much more clarity on these topics. But currently what I suggest you is to concentrate on the studies on 10th standard, develop a passion for science and those related topics, science and mathematics. I think you will definitely be guided and helped by a teachers to take your path forward. There is a question on Chandrayaan. I think this is again interesting. I think all of you know Chandrayaan 3 has been launched. The question is on Chandrayaan 4, and will it go and retrieve Chandrayaan 3 and bring back Chandrayaan 3? Of course, the goal of Chandrayaan 4 is, as we think about, is to extend the work that we have done in Chandrayaan 3. I think all of you know what Chandrayaan 3 did. The rover, the Pragyan rover, has moved on the surface of the moon and did beautiful experiments. It had 2 payloads, and all those payloads collected beautiful data, and the orbiter and the lander. The lander is still on the surface of the moon. It has landed very well and it is there. But the orbiter, after the function, it has come back to an Earth orbit, and this is again another thing that the lander, it did also an HOPE experiments. It jumped on the moon surface, but after the 14 days of its excellent scientific outcome, it is now in the sleep mode. But when Chandrayaan 4 goes, whether it will be able to pick and bring it back to Earth, I think that's something that we will not be in a position to do, and that's not the goal of any mission, to bring back a craft, because it will be very, very costly to bring back the entire craft, which weighs very heavy, maybe around half a ton. It will not be a good idea to bring it back. But what we want to bring back is the moon itself. Some part of the moon we should bring back, not the one which we sent there. So Chandrayaan 4's objective is to go there, collect the sample of various nature. That could be subsurface sample, the surface sample, drill and collect some samples, and all of this should be in a position to be collected in a capsule and brought back to Earth in a very containerized form, so that we can do analysis of it and have greater understanding of the moon. I think that will be more worthwhile while we go to moon in the next time. So Chandrayaan 3 is precisely designed to do that function. Of course, when we have huge capability later, we should be able to go in a craft and bring back the craft from moon surface one day, but that requires huge rocket capability and launch capability. With the current launcher capability to bring back the entire craft that went to the moon, to bring back it takes you huge money and effort. That won't be an economical proposition for time being. There is a question from Mr. Shashank Gudutur. I asked a question whether ISRO is planning for an asteroid sample return mission. Okay, very good idea. we should do that. I fully endorse that your idea of going to an asteroid and bring back sample. I think all of you are aware of the recent asteroid sample missions done by other nations. But asteroid missions takes very long years because they are not very near, and we need to send a probe there. It will take few years to reach there, and after collecting the sample from the asteroid, it will take again a few more years to come back and be collected on Earth. It is possible with the technology that we have today to envision such a mission and plan. When a right opportunity comes, an asteroid which comes closer to Earth, we should be able to do this. And we should also look at those asteroids' nature, the characteristics, what exactly that we are trying to find out from the asteroid, whether the asteroid has solid surface to go there and collect, or it's going to be a watery ice asteroid where you will not be able to land and collect, or it will be able to be passing through the tail and collect samples and materials from the asteroids and come back. There are different concepts and ideas. We should look at all of them and do a detailed study in the future. There is a question from Mr. Rani Chatterjee. She asked a question. She asked 3 questions, but I just take one question. Can an astrophysicist be a part of a space mission? Of course, an astrophysicist can definitely be a part of a space mission, provided there is an astrophysics related physics related experiment that is planned in a space mission. For example, in a mission to International Space Station, and we set up an observation to look at a space event, and astrophysicists would like to go there and then observe it and then be part of that mission. Of course, that can be a part of such a mission. Mr. Johan asked a question, why ISRO is spending huge amount of money to work on satellites like an NISR, which according to him it's cost $1.5 billion, whereas others in European Space Agency, they have much lesser cost for doing advanced satellite technology, which should be only $350 million US. And I would like to tell you, Mr. Johan, that of course the NISR is a very costly satellite. It costs you something like that, but then it is a shared satellite between the US and India. The component of the cost of the Indian side and the component of the cost on the US side are different. Though the part of the work that we are doing contains one part of the radar, the S-band radar is built by ISRO, and the L-band radar is built by US. And these 2 radar payloads are there, and there is a large deployable antenna which is also supplied by the USA side. But the basic satellite, the bus of the satellite, the propulsion system are all built by ISRO, and we are also doing the launching of the satellite. So there is a considerable amount of work that we are also doing. But I can tell you the cost that we are incurring to build this is actually very, very less. The Indian side of the NISR cost is actually very low. I won't disclose it for the time being. It is typically of any satellite missions that we are doing, and it's not extremely costly at all. But of course, on the US side, they have their own costing and their own expenditure, which I don't want to comment on it. So I can tell you that we are able to get very huge amount of scientific data out of this joint work that we are doing between the US and India, and it is not extremely costly for the outcome that we are going to get out of this mission. So I would like to put you at ease that we are competitive, extremely cost competitive as anybody else. Otherwise, we would not be able to do such missions together. There is a question from Mr. Samrat. He asked, how does ISRO plan to contribute to global advancement in space technology and exploration? As we already announced that all the work that we do are, especially in the domain of exploration and science, are in the collaborative mode. It is never just for India alone. Whatever we find out of scientific missions are shared between nations. We have a policy that our science data center, the data that comes out of science missions, especially the missions like the Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, Mars orbiter mission, AstroSat missions, the ExpoSat missions, all these data will be available to the global scientific community. Though there will be a certain amount of lock-in period for the project scientists to use at first, but later entire data will be made available to the scientists, including the Aditya L1. So it's a policy in the science domain that, and this is true in case of other space nations, and they also share as much data they can share with all the global scientists. So scientists, especially looking at the space science domain, do share the data, and we contribute this manner to the global exploration and technology growth. Oh, there is a question which is given by Mr. Newton Anthony online. This is available. So, let me take their question. What are the key priorities and goals of the ISRO in the next decade, and how do you plan to achieve them? I think these questions are more into the programmatic and planning aspect of it, which of course, if I start talking about it, take quite a long time. So, I won't venture into answering those type of questions, but it will be more interesting to look at questions like what Avinash has asked. Avinash Sharat Chandra Purandare asked this question: what are the opportunities for geology students in Indian space industry and ISRO, and what are the prospects of planetary geology in ISRO? So, many of you may not know that even geologists have an opportunity in space science. There are geologists who are already part of our space department, who specifically have been working with ISRO in terms of many of our earlier missions, to especially the Earth observation missions. Tectonics is something that we look at. Even geological features that extracting out of the images are very crucial for understanding even the water presence. I think those features are very crucial for how much the charging of the water takes place into the earth, and where if you drill that you should be able to look at water. The terrain mapping, it's very, very important. Those people are part of the understanding of the observation from earth, from the satellites. And even planetary geology is also important. Some of the scientists who are working in planetary geology are there with ISRO, and they contribute to building the instruments that we send to Moon and Mars, and some of the interesting findings of them are already available in the open literature. So, you are welcome to look at it. So, even geologists have huge opportunities in space technology, like many other domains like the water, the agriculture scientist, and even ocean scientist. Let me talk about another question. Mr. Mokshil Shah asks now, how exoplanets, I think this is called exoplanets maybe, he talks about exoplanet research is important for human life on other planet. So, he asked also a question about alien life. All of you know that exoplanet or exosolar planets are the planets around other suns. So, suns are the stars. Our star is the sun, and around the sun we have the solar system. But suppose there is a star outside the solar system, like the Alpha Centauri, it also has a planetary system, and many other stars have. And these planetary systems have maybe like Earth, as many planets as there are. But then as far as I know, till now we have discovered almost 5,000 exosolar planets, and some of them could be habitable by the understanding that we have today, especially looking at the atmosphere of those planets through various techniques. It has been found out to be in that region of in the system, such a way that the water is present as water, liquid water there. The temperatures are conducive for life to exist, and possibly life may be there, but they are far away. They are light years, hundreds of light years away, and they cannot be easily accessed. So, we can only say that today to understand about exosolar planets are very important, and lot of research is being done in terms of identifying exosolar planets, locating exosolar planets. Possibly you know that in India also PRL has done research to find out exosolar planets, and they have already declared them. And we also have plans to look at the atmosphere of these exosolar planets in a spectroscopic manner, and look at the elemental composition of these planets to see whether there are life possible on those planets. Such research are happening, and I am very sure with the due course of time, human beings will find way to reach up to that and then colonize one day. So, that is the importance of the exosolar planets. It is a home away from home. And of course, you talk about aliens in those planets. Aliens are nothing but other life forms. They could be intelligent and may not be as intelligent as yours. And if you are able to detect a life form in another planet, could be the nature of the life form could be different than what we have, but at least for time being, let us assume the life form is similar to the way that we have here on Earth, with water and carbon and oxygen, and all those elemental composition that we have is the life that is created. The complex molecules, the proteins and the DNAs are still the structures that are available there. Then it will be an exciting thing to know about it, and hopefully in hundreds of years of time from now, we should be in a position to know about it, if not tens of years. Mr. Ramjit asked a question. What is the purpose of building a space station? How it will impact India's growth? That's really a good question. And why should we build Bharati Antarikshya Station? I answered it little while ago, why we are building a space station. Human space flight capability is something that we are developing. I think it is not India alone. Every other nation who have an access to space technology are trying to develop this capability. Because human beings in space is like the explorers. They go beyond the shores of comfort. They want to travel far beyond and understand what the universe presents themselves to be. One of the shores that you have to cross is the gravity field of Earth and then go beyond it. I think that's why we went to moon. And human being will continue to do this exploration. But human being has another capability of the dexterity and the operational capability unlike a robot. And they should be in a position to do many things in space. And if you are to ever to go travel beyond Earth and colonize on another planet, human beings must have an ability to travel beyond Earth. Space station is such a habitable place outside the comfort zone of Earth to create that type of capability and skill in human being for long duration space travel. Years of long duration space travel are required for people to go to Mars. Mars typically takes 6 months, and maybe exosolar planets hundreds of years, maybe more. If that has to ever happen, the first step of going to moon, going to space station is necessary. But if you look at the immediate benefit of going to space station, I find the microgravity environment presents itself a wonderful opportunity to do a lot of scientific research. For example, microgravity environment provides a condition by which the material structures will behave totally differently than in a gravity field. Because of that, you can form pure crystals. I can tell you that even fibers, glass fibers that we draw for optical communication will be of very high quality if you do it in space. And they will be in a position to transmit much higher data rate than for the fibers that you are able to make on Earth. Because the crystallization of the glass, what happens under gravity environment will be different than that happens in zero gravity. Similarly, we look at the medical synthesis, the molecules, complex molecules, heavy molecules are synthesized in zero gravity environment much better. Even organs of anybody, if you want to print the additive manufacturing processes, we can do it in zero gravity environment better because they don't collapse. And there are many other scientific technical research possibilities in microgravity, and this gives a huge opportunity for us to make use of space station for immediate benefit. Let me look at a question Mr. Bishal asked. He asked a question, is India planning to develop a heavier payload rocket similar to that like others? Of course, we should develop, there is no doubt about it. We have been thinking about it for a while. Currently, we have capability to lift at least some 10 tons to low Earth orbit exist with our LVM-3. That is almost about 4 to 4.5 tons to geosynchronous transfer orbit. But for us to do future missions like the continued human spaceflight mission, building space station, or even going to moon requires huge capability. But then when you develop a rocket, it is a long-term investment. We are spending a lot of money, and we must find returns for that money. It's very important for us, and we just don't want to showcase that we have heavier payload capability. So the commercial and utilizational aspect of it is always we look at when we invest in building a new rocket. So currently we are looking at the new rocket development with that angle. How much should be the capability? Whether it will serve sectors like launching regular satellites as well as building space station. Whether it will help us to take human beings to moon. So we would like to look at a modular concept of a rocket which will help us to do everything. With a one concept, we should be able to do regular heavier launches of satellites to building space stations, maybe future take it up to the moon. I think this is the way we are looking at it, and we should also look at how this future rocket should be cost effective, we should be environmental friendly and easy to produce, and should sustain at least for 20-25 years of our demand of meeting all those requirements that we are envisioned today. This is how we are trying to look at our new rocket. Okay, so let me look at some of the questions that are now available online. Online questions, I think I have already answered. Then let me go back to my questions which are already available. Mr. Manash Kandelwal, I think he asked a question, is ISRO doing any mission related to agriculture or will it do it in the future? Of course, we have already done missions to support agriculture activities, and we will be continuing to do this missions, such missions in the future. If you look at agriculture, what exactly that we can do from space? Agriculture in India is spread across small and medium and large areas, and many crops are being done. And we face a lot of problems in agriculture. One of them is related to the drought, the water stressing, water scarcity, land utility, whether the land is suitable for agriculture, whether the crop is growing very well, whether pesticides are to be applied, whether the insecticides need to be applied, there are disease spreading, what is the yield of the crop that is just ready for harvesting, what type of crops that you can actually find place where you should advise people to go for, what type of crops, advisories that you can give. Can you help in terms of insurance? In case the crop yield is not better, they suffer due to the vagaries of the weather. I think flooding, you look at how you can look at flooding and how warn people in case these related things are there. So there are many questions that you can address which are related to agriculture. So we do satellites which will feed into this type of input, and we have various Earth observation satellites in multiple domains. We look at the high resolution satellite, medium resolution satellite in various spectral bands to differentiate one crop to another. So by appropriate testing, we should be able to identify the type of crop and crop growth rate. We also look at the earth and then look at the salinity, the mineral content, also the water content in the earth. We also look at the land areas and identify which are the right locations for future agricultural suggestions, what are the things that you can do. We also have developed tools and methods by which that you can actually observe the growth of agriculture from seeding to the harvesting. So you can make a prediction on harvesting, and this data is available with our departments of agriculture to make crop forecast predictions to help decision making. And in the future, we will be building better agriculture satellites with better sensors to look at various other elements in spectral and observation and in different resolutions. And there is a concept called AgriSat that we are looking at how to build it along with our agriculture department of Government of India to support the farmers and decision makers in agriculture. Swati asked a question, how does ISRO address the challenge of space traffic management and congestion in Earth orbit? Swati, this is a very interesting topic. I think all of you are interested, and also there is a question from Anirudh. He is asking question about space junk, space debris, how it causes a problem in the space exploration in the future, and does it cause problem, and what are the solutions? I think both these questions look at the space as a sustainable playground for all of us to play safely in the future. I think all of you realize that the space is now becoming congested at various orbits. The number of satellites that are launched in the last few years are so many, and the number of debris, both active and non-active satellites, and as well as pieces which are flying around in various sizes and shapes, have reached very exorbitant proportions. Today that we know that there are lakhs of small pieces which are flying around, they are called space junk, and they can have potential hazards in terms of proximity to the operational satellites or collision with the satellites, or even our rocket launches. We need to worry about all of them. The challenges today are observation capability, whether we are able to see all of them. Today the various observation capability limit us to something like 10 centimeter in size, but then technologies are being developed to look at objects which are smaller than that, and we have to catalog them and observe them and predict them where they will be in the next hour, in the next day, next year, so that we will be in a position to launch our appropriately the required satellites. And if they ever come closer, we should be able to warn those satellites which are having control left. Suppose one is a dead satellite and another is a working satellite, we should be able to move the working satellite so that it does not have collision. And place like Space Station, which is a huge object, and anything coming nearby can cause very dangerous situations like leak and puncture on the pressurized compartment, or even if it hits an astronaut, you can kill him instantly. So this poses huge challenges. So what you can do today is to regulate the creation of space debris in the future, and that ISRO wants to do, and we already announced that we should not be creating any more debris in space. Some of the guidelines are we should not cause any non-functional satellite to be left behind. If the life is over, we should deorbit them as much as possible. If you don't deorbit, its life should be kept as less as possible. So, we should automatically re-enter the Earth. The rocket part should always be made to re-enter with low lifespan. There shall be no left out propellant or gases in the stages or rockets or satellites which will cause explosion. And we should not cause any collisions intentionally or unintentionally. There are many things that we need to do, and we should encourage everybody to make sure that you follow these type of guidelines, both governmental and private builders. And we have announced that we should do it from India at least. And we want every other nation who have a responsibility to use space as a safe place for all of us should adhere to such principles and then come out with their own guidelines and stick to them while they do the business of space. And this is what we think about it. But then the space debris which are already there, I know that it will take years together, maybe hundreds of years to come down and vanish, but then let us make a resolve that we will not add more debris to them in the future. There is a question from a person, I don't know his name, but then the question is on a methalox engine, LOX methane engine, I believe. Methalox engine is nothing but the fuel is methane and the oxidizer is liquid oxygen. So all of you know that the methane is considered as the best fuel, rocket fuel, because of the simplicity of the fuel. It is only CH4, carbon and hydrogen, and it can be synthesized out of carbon dioxide and water. And when it works with oxygen, it gives you a very good specific impulse. So it is equivalent to a semi-cryogenic engine. And methane also can be compressed to form a liquid at a moderately low temperature, and it can be maintained. Unlike hydrogen, it has a very high density impulse which allows this to be stored in a smaller tank volume. So it has a lesser efficiency than a cryogenic engine. This gives you capacity to produce engines with high thrust and with high density impulse. That's a advantage of methalox engines, and ISRO is also interested to develop this engine. Currently we have no engines of that type. So what we did is we made use of one of our cryogenic engine and tested a methane based engine as a test sample, and we could achieve success in that. Our liquid propulsion system center did that test and it was very good, and we want to scale it up to a heavy engine, typically 100 ton plus capability. Currently that design is going on, and it will take certain years to develop this engine capability and come out with a functioning engine. But with that engine only, I am very sure that our future rockets will be built around that engine, which is very crucial for us, because we need to move to heavy thrust liquid engines with high density impulse and reusability, and also greener engines for us to sustain the space program in a very effective, cost effective manner. There is a question from Mr. Levin. The question is, why can't we build a launch pad at Vikrama Sarabhai Space Center to bring down the cost of launch, because most manufacturing is done around that. That's not a true statement. Possibly you might not know the rocket parts are built all around the country. I can tell you, for example, the steel is manufactured in somewhere near Hyderabad. It goes to Rourkela and get rolled into steel sheets. It comes to Mumbai, get manufactured as motor cases. The aluminum comes from some other plant across the country that gets into tanks at industries in Bangalore. The propellants are made in faraway places. The electronics manufactured all across the country, and control systems and elements comes from various resources. So, and they all come together to the Sriharikota, the launch station, and get assembled to build the rocket. And why we built the launch pad at Sriharikota is precisely because of the geographical location that it is best suited for it to be launched towards eastern direction. So the right place today we have for launches for satellite missions is Satish Dhawan Space Center, and we are also coming up with a new launch station at Kulasekarapatanam in Tamil Nadu for launches towards southern direction. But for eastern and direction, as well as for communication satellites, Satish Dhawan Space Center is the best suited launch location for us. So, I think we have covered quite a bit of subjects today. Thank you so much, and looking forward to another session when we announce. And till then, let me wish all the very best to you, and looking for very exciting questions and suggestions from each one of you. Thank you.